Hello class, and welcome to lesson 5.7. Today we're going to learn a second method called the square root method in order to solve quadratics. However, before we do that, let's practice last day's lesson, which was solve by factoring. So I'd like you to pause the video and try these warm-ups and then unpause the video and check your results. Okay, pause. Okay, class, hopefully you paused, and welcome back. Here's how you should have solved these, ladies and gentlemen. Hopefully you looked at the first one and you said, hey, I can common factor out a 4d. So you got 4d times d minus 6 equals 0. Then you use the zero product property, which means either 4d equals 0 or d minus 6 equals 0. And again, if you can go right to the automatic answer, I'm okay with that. But we're going to divide both sides by 4. So d equals 0. That's one answer. And d equals 6. You take the negative 6 and bring it over. All right. Second example, solve by factoring. Before we can do anything here, you need to bring all the terms to the left. So that 2w is going to become minus 2w. Minus 24 equals 0. Now we're going to do our product equals negative 24. And our sum, folks, equals negative 2. What two numbers do we have? 4 times negative 6. So it's going to be w plus 4 times w minus 6 equals 0. Now, ladies and gentlemen, you can show me, remember the shortcut from last class? What value must w be in order for this whole binomial to equal 0? W equals negative 4. It's one solution. Or the other one, what value to put in for this w, the second one? And that's going to be w equals 6. If you're not sure, you can still do the t-chart like what we did up above and solve each. So for example, you could go w minus 6 equals 0, bring the negative 6 over, and w equals 6. But again, if you need that, go for it. Otherwise, you can just simply stick with those ones. All right, so I'll erase this so it's not confusing if people are printing it off after. Okay, taking a look at C, ladies and gentlemen, we're going to move all the terms to the left. So we've got 20q squared plus 70q plus 60 when you bring that over equals 0. Okay, look at our expressions, folks, and hopefully you realize that we can divide every term by 10. So I'm going to put down here divide by 10. So I'm going to have 2q squared plus 7q plus 6 equals 0. All right, so we still notice, ladies and gentlemen, that we have a trinomial here where a does not equal 1, so it's decomposition. So we're going to split the middle term. So what are we going to do, folks? Remember, product equals a times c, so product equals 12, sum equals 7. What are our two factors there? 3 times 4. So I'm going to write my first term here. Just going to split the middle term just because I ran out of room here. So that's going to be plus 3q plus 4q, and then plus 6 equals 0. Okay? Now what's common in the first two terms? You should see that we have a q, so you're left with 2q plus 3. And what's common in the second two bracket, or the last two, you should say a 2. So you're going to be left with 2q plus 3 equals 0. Common binomial, folks, is 2q plus 3. And your leftover makes the other factor is q plus 2 equals 0. Okay, this one may be harder for you to figure out, so you may want to do the t-chart for this because you're going to have a fraction. 2q plus 3 equals 0. Get the 2q term by itself, so 2q equals negative 3. To get q by itself, divide both sides by 2. So q equals negative 3 over 2. Okay? On the other factor, q plus 2 equals 0. This one's going to be easier. Q equals negative 2. All right, so just remember, guys, that when you have a decomposition, you'll always have one of your roots that's a fraction. All right, folks, so that was method 1, solve by factoring. Today we're going to use method 2, which is solve by square root method. So we're going to be taking square roots. Okay? All right. So today we're dealing with quadratics equations, and we're going to solve using square roots. So I've tried a different design here, folks, where I've completed the lesson and we're just going to use a shield that goes up and down. Okay, and hopefully this helps. If not, I'd love some feedback on it. Okay, so recall factoring x squared minus 9 equals 0. If we solve by factoring, that's a difference of squares method, one we didn't do in the warm-ups, which is x plus 3 times x minus 3. All right. Okay. To solve it, you let each bracket equal 0, and you're going to end up with x equals negative 3 and x equals 3. I don't necessarily need that step, but if you need it to see what's going on, by all means, go ahead. Therefore, folks, the roots are plus or minus 3. So that's something that's new. When we did Pythagorean theorem, folks, and say we had something like b squared equals 25, and we took the square root, we would say b equals the square root of 25, and we would say b equals 5. Because when we deal with measurement, ladies and gentlemen, it's always going to be positive. However, I want you to think about this. I want you to think 5 times 5 equals 25, right? However, there's another possible answer. Negative 5 times negative 5 will also give you 25. So now when we do the square root method, you're always going to be taking the positive and the negative root. So you're going to see that a fair bit in the next couple days. Okay? All right. So remember that the plus and minus means both positive and negative values. All right. So let's try an example here. Let's try to solve without factoring. Okay, so what we have is we have x squared minus 9 equals 0. Luckily, folks, the x term, there's only one of them. So we can take the negative 9, move it over, it becomes positive 9. And then, folks, to get x by itself, currently it's squared. You have to do the opposite operation, which is square root. So take the square root of 9. Be careful, folks. When you take the square root of 9, you've got to take the positive and the negative root. That is new. Okay? So therefore, the roots are 3 and negative 3. Okay? So the symbol, plus or minus, represents both positive and negative signs. Okay? So that's an easy example where you have a difference of squares that you can solve. Okay? All right. Let's try another one on the next page. We're going to get a little harder. Okay? So notice that was just like an x squared minus 9. So it was a difference of squares. We're going to make things a little different in the second example, because in the second example here, we have a binomial squared equals 10. However, the good news is, folks, x is still one term. That's going to change in the third example, and that's going to make it a little harder for us to solve. So I'm going to need you to stay focused with me, especially when we go through that one. All right. So currently, folks, we've got x plus 5 squared on the left side, and on the right side, we've got equals 10. Well, if we want to get x by itself, we've got to deal with that squared. The opposite of squaring is to square root. Okay? So what we're going to do is take the square root. So basically, I'm going to show you what happens. You take the square root of the left. Whatever you do to the left side, you do the same to the right. However, folks, squaring and square rooting cancel each other out. So that's why you're left with x plus 5 equals plus or minus root 10. Okay? All right, so we're taking the square root of both sides. Okay? Squaring and square rooting are opposite operations, so they cancel. And now, folks, it's going to be easier for us to solve for x, because x is going to get by itself soon. Okay? So we have two cases, folks. So we've got x plus 5 equals the positive root 10, or x plus 5 equals the negative root 10. Okay? So that's going to give us two answers. In order to finish this up, we isolate the variable. So you take the plus 5, bring it over, and it becomes negative in both cases. And then you just plug this in your calculator by solving. Okay? Now I showed a couple more steps that need to be, guys. You can actually just plug it in your calculator and go root 10 minus 5 and get this answer. Normally we'll just round to 2 decimal places. I thought since it was the first time you're seeing it and it's a video that I would show you a couple more decimal places. I don't need to see this second step. You can just plug it right in your calculator because most people have a good calculator these days. All right? And what you're going to have is, therefore, there are two roots. So one root is, if we rounded it to two decimal places, it'd be negative 1.84. And x equals negative 8.16. Those would be your two roots. Okay. Notice, folks, you've got decimals here. You wouldn't be able to do that with factoring, so that's why we teach you another method. And it's in the form where you can easily take the square root. Okay, so that's the second example. Now the third example, please put your thinking caps on and stay with me because it's not so easy. And I'll show you why it's tricky. All right, so for the third example, I'll shade it up so it doesn't look so overwhelming. Okay, so for third example, folks, notice the problem here. We have a bx term. So when we have a bx term and an x squared term, we can't just get x by itself because we can't collect those terms because one's squared and one's singular. Okay, so we've got to find a different strategy. So what we're going to use is something called completing the square method. Okay, we can try factoring, but we won't be able to factor. Why not? Because the product equals 2 and the sum equals negative 6. My only product of 2 is negative 1 times 2. Okay, and that won't work. So we can't factor. Okay, so now we need to learn how to do it the hard way. Okay, and the hard way is going to be called completing the square. Okay, so you want to write that down. Complete the square. Okay, and you will use this especially in grade 11 as well and later on in this unit. Okay, so you're going to want to be able to pay attention to this. Okay, so step number 1, we need to move the constant term to the right side. Okay, and the reason we need to do that is because we're going to get all the x terms on the left. Okay, and what we want to develop is what's called a perfect square. So a perfect square is going to be where we have two factors, and a perfect square, folks, gets it to an example like this. Okay, so a perfect square gets it to an example like that, where you can actually take the square root. And just give me a second, I'm going to pause my video. Hey guys, sorry about that. Just had a little visit with somebody, so I'm back. So we were talking about the third example, folks, and it's tricky because we've got an x squared value and an x value. So if you have the bx or the middle term showing, then you're going to use what's called complete the square method. Okay, and we're going to take what we have here in step 1 and end up like what we had in example 2 here. So we're going to complete the square so that we've got two factors that are the same, so we can square it, so then we can eventually take the square root. Okay, so stay with me, folks. I know this example is done for you. I plan to do 2 of your homework questions together with you to make sure for this one you're on track. Okay, so to complete the we're going to create a perfect square on the left side. So what we need to do, and this is the key thing, you're going to take b and divide it by 2 and then square it. So based on this equation, okay, so based on what we have, folks, off in a side margin, I want you to write b divided by 2. So b in this case, folks, is negative 6. So you go negative 6 divided by 2 equals negative 3. So far, so good? Okay. The next thing we need to do is take whatever our answer is from the first line and square it. Okay, you're going to say, Miss R, this is crazy. Why are we doing this? And I'll explain it after. So you're going to take negative 3 and square it, and that's going to equal 9. So what we want to do is to balance it out, we want to take this 9 and add it to both sides. Okay? So now, folks, you're saying, great, Miss R, we got a trinomial on the side. But I want you to just take a second and think about that. If I've got a product, it equals 9. And I got a sum that equals negative 6. What two factors that must be the same fit this case? And you're going to see that it's negative 3 times negative 3. So if I go to factor the left side, and I'm just showing you this, it's going to be x minus 3 times x minus 3. So you wouldn't leave it in that form. You would say that it's x minus 3 squared. Okay, so what happens is we had to get rid of the constant because it wasn't a perfect square, move it to the other side over here, and then we had to come up with a new number, which was this 9. Okay, and that's a magic number that we come up with in the side margin over here. Okay, and that allows us to complete the square, which means, hey, what's my product such that my middle term, okay, if you divide it by 2 and then you square it. Think about the backwards method, guys. Do you know when you've got x minus 3 and you square it, okay, and you expand it, you square the first, which is x squared. You double the product. That double the product, which we get in the middle term, which is negative 6x. That is the opposite of what we do here. Instead of doubling the product, we're going to take the middle term and dividing it by 2 to get us in the middle, and then you square the last. We have to square it in order to get that third term. Okay? So that is how we come up with this, and trust me, we'll do a couple more examples. I think you'll feel better. So 9 is added to both sides. Okay? Once 9 is added, you can either just say factor out the left side, or here's the hint, guys. Over here, ladies and gentlemen, up in the margin, we actually put the value that belongs in the binomial. That's why we break it into 2 steps. So it's x minus 3 squared equals negative 2 plus 9, which is 7. Now we're just back to the same as example 2. Now we're going to take the square root of both sides. So if I take the square root of the left and the square root of the right, we need to cancel those out. Okay? So we are left with x minus 3 equals plus or minus 7. Okay? You can take the square root to solve. You can solve each square root. Now another example that I like to do, folks, instead of splitting it into each case, sometimes people go like this: x equals plus or minus root 7, and then they go plus 3, then they split into 2 cases. I find this is actually an easier method, but it doesn't matter which way you do it, you will still get to the same answers. And again, you're going to get to this stage where you're here, where you split it into 2 cases, and again you can jump right from there to the last example. Okay, so therefore our roots are going to be 5.65 and 0.35. Those are our 2 roots. Okay, here's your homework, ladies and gentlemen, but don't hang up on me yet, because we are going to do some of these examples together. Okay, don't want to leave you hanging dry. Okay, so I'm taking one example from 1 and 2, and then we'll do a couple from 7, just to make sure we're on the right track. All right, so ladies and gentlemen, example 1, when you have x squared minus a number, you can take the negative 36, bring it over to the other side, and that equals positive 36. Okay? Now to get x by itself, you take the square root of it, and whatever you do to one side, you do to the other, and you put it a plus minus. So x equals plus or minus, what's the square root of 36? It is 6. So your answers are plus or minus 6, or x equals 6, and x equals negative 6. All right. Second example, it's easier because you have one x expression, and it's in a binomial squared. Okay, so simply to get this to get the x by itself, you got to start getting rid of the exponent. So you got to do the opposite of squaring, which is square rooting. Whatever you do to one side, you do the same to the other. So you're going to have x plus 2 equals plus or minus root 3. Because squaring and square rooting cancel each other out. I like to do it this way, guys. I like to go x equals plus or minus root 3 minus 2, and then I'm going to break them into its 2 cases. And if you'd like to save room, you can do things like this. I don't care, as long as you show me some arrows. Break it into 2 cases. So x equals the positive root 3 minus 2, or x equals negative root 3 minus 2. Now be careful when you plug the negative 1 in your calculator. You may need to put brackets around your root 3. Okay? All right, I apologize. I don't have my answers with me, so give me a second. I got to grab a calculator. Let's do that, guys. So square root of 3 minus 2 equals, so I have here negative 0.27 rounded. And for example 2, you have to go negative square root 3 minus 2. So negative 3.73. So those are your answers. And again, folks, you wouldn't be able to factor these because you've got decimals. So I've learned more than one strategy. Okay, let's try 2 of the more harder ones, guys. This example 3, I want to get your head in the right direction. Make sure you're good with this. I apologize, taking a look here, folks. I forgot to write my x down. Okay, so folks, I got a trinomial here, which means I've got an x squared and an x term. Step one, folks, is to get the constant term on the other side. And it becomes negative 24. Everybody good with that? Now we have to realize, we can't leave it here, folks, because you can't get an even square. You need to have a perfect square there. So you need to have the numbers 1, 4, 9, 16, 25. So things that are on your diagonal in your matrix, okay? So that doesn't work, so you bring it over to get it out of the way. Now to find that third term that's going to go there to make it a perfect square, we have to do our margin work. So b divided by 2 equals 10 divided by 2, which equals 5. Okay, and then you got to square that. So equals 5 squared, which equals 25. That's the number you're going to add to both sides. Just give me 1 second and I'll put it in there. Okay, so I'm going to add 25 to the left side, and I'm going to add 25 to the right side. Everybody good with that? Okay. Now what we have is what's called a perfect square. So you can take the square root of this or factor it out. So if you need help with this, guys, product equals 25, sum equals 10. What two numbers multiply to 25 and sum to 10? That's going to be 5 times 5. So this is going to be x plus 5 squared, right? Okay, equals negative 24 plus 25 is positive 1. Shortcut here, folks, if you're looking for that number, it's your first value in the margin. That's why we split it up. Now, folks, we can use example like example 2 up there. We can take the square root of both sides. So it's going to be x plus 5 equals plus or minus square root of 1. Okay, good news is, folks, what's the square root of 1? It is going to be 1, right? So x equals plus or minus 1, and then minus 5, so bring the positive 5 over. Now we split it into our two cases. Okay, so x equals 1 minus 5, so x equals negative 4. Or we do the second one, x equals negative 1 minus 5, so x equals negative 6. There are your two answers. Okay, I'm just going to make sure that looks like a negative 4, guys, because it looks like it's attached to the equal sign. Awesome. Okay, last example, guys. If you want, why don't you try it yourself ahead of time, pause, and then check the answer after. I'd prefer you to do that. Okay, so pause, give it a try, see if you can do it. Okay, welcome back, guys. Hopefully you gave this a try. First thing, taking a look at our trinomial. Negative 10 isn't a perfect square, so we're going to put it over the other side. So we go x squared plus 18x equals 10. Okay, now to find that third term that will help us create a perfect square, we have to take our b value, divide by 2. So that's going to be 18 divided by 2, which equals 9. Just double check, folks. Let me just make sure before we start here that I got the question written down correctly. I got to double check that. Oh boy. So I apologize, guys. I have to start over. Luckily, we didn't get too far in. Okay, I wrote the question down wrong. Sorry. Okay, my fault. Okay, so taking a look, 7d is x squared minus 8x plus 10. I somehow wrote plus 18. It happens. Sorry, I make mistakes. All right, let's try that again, folks. Again, the plus 10, lady. Oops, I'm dropping markers now. The plus 10, folks, isn't a perfect square, so we got to bring it over. So it's going to be x squared minus 8x equals negative 10. All right? Okay, now we have to do our b divided by 2 work, which is negative 8 divided by 2, which equals negative 4. Okay? You're going to take that value, and remember, you got to go b divided by 2, and you got to square it. So that's equals negative 4 squared, which equals positive 16. So that's the number you're going to add to both sides. So just give me a second. I know it's kind of squishy here. So I'm going to go x squared minus 8x. I'm going to add that in a second. Okay, to both sides. So it's going to be plus 16 and plus 16. Okay, factor out the left side, or complete the perfect square, which is going to be x minus 4 squared equals, and remember, it's the square root of the first and the value that's in your margin here. Otherwise, remember, you can take this and go product equals 16, sum equals -8. What two numbers must it be? -4 times -4. They're the same factors, so that's why it's going to be squared. Okay? All right, and on the right side, we're going to simplify that to 5. Okay, I apologize. Simplify that to 6. I can get this together. Here we go. All right. Now what we're going to do, folks, now we have just one x term. That's why we had to complete the square. Now we can get rid of the squared by doing the opposite, which is square rooting. Okay, so we're going to have x minus 4 equals plus or minus root 6. I'm going to bring the -4 over. So x equals plus or minus root 6 plus 4. Okay, now I'm going to split into its two cases, guys. Okay, so x equals root 6 plus 4, and x equals -root 6 plus 4. I have to grab my calculator because I don't have the answers done, so let's just do it quickly. So square root of 6 plus 4 equals, so this first answer, first root I have is 6.45. Those are rounded. Let's try the next one here. 6 plus 4, and I have 1.55 for the second root. Okay, hopefully that gives you a bit of help, ladies and gentlemen. Please make sure that if you keep your calculator at school, that you bring it home, especially for tomorrow's lesson. Tomorrow's lesson is the third method, out of curiosity, and that's using the quadratic formula, which is that big formula. It's the biggest one you're going to use in grade 10. All right. Hopefully that gives you a bunch of help, guys. I'm sorry that I went on a longer video, but I wanted to make sure you have a complete understanding of that. Have a great day, and see me if you need some extra help.